This brings us to about the year 2000, and all this previous work had been published in engineering and veterinary journals. And in the year 2000, I attended and presented a paper on this approach to measuring lameness in horses at an IEEE bioengineering conference in Colorado. And I think I said something at the end of the talk like, well, this is a very good approach to analysis of lameness in horses, but it's not very practical because you need an equine treadmill, you need multiple high-speed cameras, and you need sophisticated kinematic gait analysis equipment, not to mention the commitment and time and effort required just to collect the data. No one or place, but the most sophisticated laboratories would really find it very useful. It was definitely not something to be used on clinical cases. However, after that presentation, an electronics engineer from Japan, Dr. Yoshiharu Yonezawa, approached me after the presentation, and although he knew nothing about horses or veterinary medicine, he thought that it might be possible to adapt this approach to data collected from body-mounted inertial sensors, about which he was an expert. So we had lunch together and for the first time sketched out on napkins actually what this system would look like, and we agreed to collaborate in the future. So now we started collaborating with Dr. Yonezawa and his research group of electronics engineers. And this picture here is actually a picture of Dr. Yonezawa and myself many years ago testing an early body-mounted inertial sensor system. The horse is somewhere off in the distance. We worked together. He provided the hardware, I provided the software and the analysis algorithms, and for the first 2 years just to develop a prototype. This takes us to about the year 2002. Radio sensor battery technology at this time was not as advanced as it is today, so our first prototype was still not very practical for everyday use, but it worked. It consisted of 4 sensors, all accelerometers, one each on the head, pelvis, right front and right hind limbs. The accelerometers on the right limbs provided an event marker for which we could partition the stride cycle into right and left parts. And actually all of the lameness evaluation came from evaluating the acceleration from the sensors on the torso. Each sensor was connected with wires to a cell phone strapped to the horse's back, and then the cell phone would transmit the data to a laptop computer. The description and use of this prototype was published in 2002 in both engineering and equine veterinary journals. We later determined that the event marking function of the limb sensors was better accomplished with gyroscopes rather than accelerometers, so we switched these sensors to gyroscopes. We actually used the system in several clinical cases, but it was by no means practical for everyday use. It just required too much time to instrument the horse, especially securing the wires that flapped up against the limbs as the horse was moving, and also the cell phone on the horse's back was problematic. However, we could at least analyze the horse's movement over several contiguous strides while it was moving over ground.